Hello again, and today we are going to be solving multi-step equations with variables on both sides. This is only a tiny bit different than what we just did last time. As you can see, I've got the same setup here. Our steps are the same, our goal is the same, pretty much everything is the same. I just want you to see some examples of how to deal with when we have variables on both sides of that equal sign. Okay? So if we can recall here, remember from last time, and you already have in your notes, it's a good refresher hopefully, our steps. So the first thing that you have to do is to distribute if needed. Remember that? Then we combine like terms. And this should be a refresher here. If you think I'm kind of speeding, you can look at the last video. And when we combine like terms, remember the important part of that. They're only can be combined if they're on the same side of the equal sign. Don't forget. Can't go combining stuff on the opposite sides of the equal sign. That is illegal. And then we solve. Yay! Everyone's favorite part. That's a creepy looking smiley face. And we are still using inverse operations or opposite operations and doing the order of operations backwards. Let's just get to it. This will be a much shorter video. I hope that if you understood what we did last time, then you'll be great at this guy. Some new examples here. Let's start with this one. As you can see, we have x's on both sides of that equal sign. Uh-oh, what do we do? It's not so bad, I promise. First, I'm going to create our wall. So we know that we can't go combining anything on different sides of that. We can't just smash them together. That's why the equal sign is there. It's a scale. They're equal to each other. They got to stay separate. It's our balance point. There's no distributing needed. So, and there are no like terms that we can combine on the same side of the equal sign. So what we have to do is first get all of our x's on one side. We want to keep our x's away from everyone else, right? And away from us. You can move them to either side. It does not matter what side you move them to of the equal sign. My tip, you may or may not want to use my tip. So I'll put tip. I move the smaller. I move the term with the smaller coefficient. Remove the smaller x or variable. I do that so we don't end up negative. Now, again, you can do it either way. It will give you the same answer. I like to move the smaller one so we don't end up with a negative variable. It doesn't make a difference at the end, just as we go. So this negative 3x is smaller than 5x, so I'm going to move this one that way. And how do I do that? What's the opposite of this negative 3x? I'm going to add 3x, Miss Z. To both sides. This is one whole thing. It has to move as a unit. It stays together until we break it apart. When we move it, we move the entire thing. We do the same thing to both sides, okay? So then we end up with here, that goes away, and 3x plus 5x, that's 8x's, plus 7 equals, and what's left? 31. So we've solved that problem already. Now we have our x's all together, and it's just normal. we do the opposite operations. We do the order of operations backwards. So we are going to subtract first. Those go away. And then to undo multiplication, we divide. And x equals 3. Not so bad, right? I'm going to leave it up here for a minute. So you can see the steps, follow the steps. If you need to take a picture of the video, screenshot, pause it, go back, do whatever you need to do to make sure that you have this stuff in your notes and you write down each step. That will be very helpful to you. Do I sound like a broken record yet? I want you to go ahead and try this one by yourself. So go ahead and pause the video. I'm going to go with it's been a few minutes here and you've tried it yourself. And now we can do it together. It'll be really, if you didn't pause it and try it first, it's going to be a little more difficult for you to complete your practice problem. So I really highly suggest that you actually work out the problem on your own before I do it with you here. But let's just get down to it. We don't have any distributing. We don't have any combining. We're going to, I like to move the variable first. So I almost started doing that opposite for you. It doesn't matter what you do, but to stay in the same kind of steps, I look for the smaller one and I move that first. So 9x is smaller than 11x. So I'm going to subtract 9x's from both sides. They go away here. Now we have all our x's on one side, and we do the same steps that we're used to. We do the opposite operations. We're going to subtract 6 from both sides. We're left with 2x over here, and 2x equals 4. Divide by 2. 2 equals x, or x equals 2. Ta-da! We're going to add in another little piece here with distributing. So we have to distribute. That means that we take this and share it. And we're going to take this 3 and share it. So we have to distribute all of it. I'm okay if you distribute everything in at one time in one go. So we'll start with the left side. 6 times 2x is 12x. 6 times 1 is 6. And that equals 3 times x is 3x's. 3 times minus 4, or negative 4, is negative 12. We shared that. We used a distributive property. Now we need to combine like terms. There are no like terms on either side here that we can combine. So now we want to get all of our x's at one place. I'm going to move the smaller 3x. Drop everything else down. And then I'm going to subtract the 6 from both sides. Negative 12 minus 6 is negative 18. And then we undo multiplication by dividing, and we end up with x equals negative 2, and we're good. Next one. Try it on your own, so go ahead and pause. Welcome back. First thing I'm going to do is I'm going to make our little barrier so we can remember that we're working on each side of the equal sign. Before you do anything, you distribute. That's step one. So I am going to copy down this left side of the equation just how it is. And then I'm going to distribute over here. So 5 times x is 5x, and 5 times 2 is 10. Now we're done distributing. See how we got this 5x and that 10? By sharing the 5. Now I'm going to look for like terms to combine. So if we look on this side of the equal sign, we see that we've got a 9x and a minus 7x. Those are like terms. We can combine them. When we combine them, we've got 9x's minus 7x's. We have 2x's, and we still have 10. And we copy down the other stuff. Now we need to get our variables on the same side. I am going to move the 2x because it's smaller. You can move the 5x if you wanted to the left, but I'm going to move the 2x to the right because it's smaller. Now we're going to move this 10 away. So we've got 0 equals 3x. We divide by 3, and we know that 0 divided by 3 is 0, or x equals 0, and that is our answer. So that one was a complicated one, but we followed our steps. We distributed. We combined like terms. Then we did our order of operations backwards. We got our variables on one side and solved. So congratulations if you've made it this far in the video. Ooh, what did I just do? That was fancy. Why is it doing that? Ooh, okay. If you've made it this far, I'm going to give you a code word, and I'm going to ask you what the code word was, and you're going to get points for it for watching the video all the way through. So those of you who are still here, congratulations. You're going to be able to answer my question. So my code word for this time is going to be banana, because I've got yellow and I'm hungry. I would draw you a banana, but I'll try. Oh goodness. Sort of. There's a banana. That's a code word. So on Google Classroom, when I ask you what my code word was, it's banana. Congratulations for making it to all the way to the end of this video. I'll talk to you guys later.